Okay, so I just checked out the video of the first 4 problems. Not bad. I'm getting warmed back up into teaching, and so could have been far worse of a video. But we're gonna finish off the other 3 examples I have left to show you before you start working on your homework. Example number 5, we're gonna look at a fraction. 1 over root 3. And how we deal with radicals in the denominator. As you should remember from Algebra 2, a radical in the denominator can't remain. Okay, it's not simplified. We have to always gonna have any radicals that gotta be in the numerator. So to get it out of the denominator, we multiply both top and bottom by the radical. Root 3 times root 3 gives us root 3 squared. Well, square root and the square function are the opposite functions, so that just turns into a 3. And 1 times root 3 is root 3 on the top. And so that becomes the simplified version for a radical when it's in the denominator. Example 6, root 24 over root 6. Couple of ways we can look at this. The first one I'm going to show you is when you have a radical on top and bottom, we can combine it into one radical and then we can reduce. 24 divided by 6 is 4, and we know that 4 is a perfect square. The square root of 4 is a 2. The other thing we can look at in radicals when you have them top and bottom is we can simplify. So we know root 24 breaks down into a 6 and a 4. 4 is a perfect square, 2 times 2. So we can actually change that root 24 into 2 root 6. And we still have the root 6 on the bottom. Well, when we had the same piece on top and bottom of a fraction, they cancel each other out. So root 6 divided by root 6 divides to 1. 2 times 1 is 2. So either way, we get the same answer regardless of which direction we decide to take the problem. The last thing to remember when simplifying radicals is sometimes we would have a radical in the denominator, but it wasn't by itself. It was part of a binomial. So 2 divided by 1 minus root 3. And as you'll recall, when we had a binomial in the denominator, to reduce that and to get the radical out of the denominator, we had to multiply by its conjugate, which its conjugate is that binomial just changing the sign in the middle. So this was 1 minus root 3. The conjugate of that denominator is 1 plus root 3. And whatever we do to the bottom, we have to do to the top. So when we multiply conjugate on the top, we have a single number here times this binomial. It's a simple distribution. 2 times 1 and 2 times root 3. So 2 times 1 is 2. 2 times root 3 is positive 2 root 3. The denominator, we have 2 binomials. We have to distribute onto both, or we like to refer to that as FOIL. So First term times first term, 1 times 1 is 1. Outside terms, 1 times a positive root 3 is positive root 3. Inside terms, negative root 3 times 1 is a negative root 3. And then last terms, negative and positive root 3, multiplying them together, will just leave us with a negative 3. By doing that, the inside and outside terms should cancel. They're opposite and they add out to a 0. So we're left with 2 plus 2 root 3 over the first and the last. 1 minus 3 is a negative 2. And in this case, that can be simplified. We have a 2, a 2, a 2. We can go through and split this up into parts and simplify it. So this becomes the same as 2 over the negative 2 plus 2 root 3 over the negative 2, and then we can reduce those. 2 divided by a negative 2 is negative 1. 2 root 3 divided by negative 2, the 2 is on the outside, so 2 divided by negative 2 is a negative 1. So instead of it plus a negative 1 root 3, it's just simply negative root 3. The 2's cancel and the negative sign sticks around in front. Okay? So negative 1 minus root 3 is our solution. Remember, the reason why we do this conjugate, just as a side note, we can look at it with any binomial, a plus b times a minus b, and we get a squared plus ab minus ab minus b squared. The ab's cancel and we're left with the first term squared minus the second term.